Good afternoon, boys and girls. We are about to tackle on the exit ticket that we had in class earlier today. It is known that 23% of cars do not pass their motor vehicle inspections the first time. We take a sample of 8 cars at the local auto body shop. Now, before we can actually do any of these problems, we must first determine if this is a Bernoulli trial, more specifically a binomial model. So again, let's look at our conditions. Are there 2 outcomes? The answer to that is yes. It's going to be a pass or a fail. The second condition, or the success is consistent. That is correct. In this case, we know that 23% fail their car inspection. So we know that that right there is consistent. So this is 0.23 and it is constant. The third condition, do we have a fixed number of trials? The answer to that is yes. We are given that our sample size is 8. And the last case is independence. Someone asks the question, well, what happens if they don't tell us that they're independent? This is when we are to say that our population is it greater than or equal to 10 times our sample size. So we know that there are more than 80 cars. So for that will come in for an inspection. Therefore, we can assume that they're independent. As a result, we can classify this as a binomial model, and we will use B, remember, B, N, comma, P. So that will be B, 8.23. Now, create the probability distribution for this scenario. When it comes to creating this, you can either do it vertically or horizontally, in which you're basically going to find the individual values. Do not forget your 0. Do not forget your 0. And it goes all the way up to A. And what you're going to do is, if they actually do this, you're going to fill in that number. So what we're going to do is, I'm not going to type this up, but I'm going to actually show you how you would utilize your calculator to find each of those marks. And so as our calculator emulator software comes up, I'll show you how to do it. So we'll clear out our calculator, 2nd plus 712. Then I go to Stats, Edit. Let me go again, 2nd plus 712. Okay, now it's clear. I go to Stats, Edit. I'm going to do 0, 1, 2, 3, 4, 5, 6, 7, 8. And what we're going to do is, remember, it is important for us to put our cursor up to the top, press enter. Then it's going to make my cursor go right here. So we're going to go to second distribution. And we're going to go all the way down to binom PDF. Press enter. There are a total of 8 trials. My P was 0.23. And my X value is going to be denoted by second L1. And paste. Press enter. And these are the values that you would use to fill out your, these are the values that you would use to fill out your screen, okay? So that's exactly what you would do. Okay, So for C, what is the probability that less than 4 will fail inspection? If you recall, it is so important for us to rewrite this using our probability notation. Less than. For our purposes, I'm going to just put it in binom CDF form or it's PDF, depending on what we're going to use. So this is the probability of X is less than 4. Remember, if it is less than, then you have to ask yourself, I know that it's going to be CDF, but because it does not include the 4, then I know that this is the same as P of X is less than or equal to 3, which I can receive binom CDF of 8.23, 3. And once I put that into the calculator, I will end up getting 0.912. The second one says, what is the probability that 6 or more fail? So we're looking at the probability X is greater than or equal to 6. Greater means that we're going to have to rewrite this. So notice that this includes the 6. So I want 1 minus the probability of X is less than or equal to 5. So this will be the same as 1 minus binom CDF, and that is 8.23, 5, and my answer will end up being 0.0027. E states, what is the probability that exactly 3 will fail inspection? So probability that is equal to 3. So for this case, we know that that is a PDF, and we get 8.233, and my answer will be 0.1844. It says, what are the mean and standard deviation of the number of cards that will fail inspection? Mean, expected value, all mean the same thing. So we're going to have mu sub x. This is our formula, n times p. So that will simply be 8 times 0.23, which gives me 1.84 cars. And my sigma of x is equal to the square root of n times p times q, or n times p times 1 minus p, which gives me the square root of 8 times 0.23 times 0.77, and we get 1.1903 cars. This represents the exit ticket that you had today. A couple of the mistakes that I noticed were that when it came to the inequalities, some of you guys failed to put the equal to sign when necessary. I noticed that part. Some of you did not remember the formula, which is okay, because that formula will always be given on the standard formula sheet. And so for the most part, that's what I noticed. Also, when it came to the conditions, it is important for you to remember each of those 4 conditions and state why or why it is not a Bernoulli trial, specifically a binomial model. And I notice we're saying specifically a binomial model because tomorrow we're going to introduce you to something called the geometric model, and it has a few different conditions. So I'm going to upload this. You will have a quiz upon entering class tomorrow that will be very similar to this exit ticket. I wish you well.